guys, welcome to the new video again. In this video, we will discuss some questions on distribution problem. Alright, distribution problem are have different types: distinct to distinct, and identical to distinct, distinct to identical, and identical to identical also. And these problems have their subtypes: ordered partition. Uh, so, subtypes are fully specified. Second is partially specified, and not specified, right? So we have already discussed fully specified and partially specified problems, and now we will discuss some more questions. So question is, distribute 15 question is distribute 15 let's say toys among 3 child and where second child gets exactly 3 toys. Gets exactly 3 toys. So how can we do this? We have to distribute 50 toys among 3 children. Where so how can we do this? There are 15 hours, alright? So we can give 3 to second child, which is 15C3, alright? And rest of them we have to distribute into 12 toys into 2 children. 2 children. There is AC. Let's say child have A and B and C. Alright. We have to distribute them to them. Alright. So uh, how many ways we can distribute 12 toys in 2? Right. So how can we distribute? How many ways we can distribute 12 toys to 2 children? Right. So toy 1, toy 2 can go for A or B. All have also have 2 options. 2 to the power 12 is the answer. Alright. So 15C3 into 2 to the power 12 is the answer, final answer for us. Because it is partially specified, but this is fully specified. Fully specified. Next question we will discuss is, distribute 10 toys among 3 children. Distribute 10 toys among 3 children, where first child get at least 2 toys. Where first child gets at least at least 2 toys. This is our question. How can we do this? So child A plus child B plus child C, right, equal to 10, where B has at least two toys, right? So 10, these are not identical, not identical. So this is not the way, not the way to do it, right? Because toys are distinct in themselves. So this is not the way. So how can we do this? Toy 1, let's say toy 1, toy 2, toy 3, toy 4, and toy 10, 10 toys. It can go from 10, we can give first child, right? He or she had no restriction for first child for A. What we can do is at least two toys. At least means not 0, not 1, greater than equal to 2, right? So this can be solved by complement method. Complement method. What is the complement method? Total minus exactly 0 minus exactly 1. This is the complement. Hmm. Exactly 0. Total, how total is what? Toy 1 can go for A or B or C, right? So total is like 3 choices, 3 to power 10, right? Minus exactly 0 means what? Exactly 0 is 10C0 into 2 to power 10, right? And exactly 1 is like 10C0 into 2 to power 10 minus exactly 1 is like 10C1 into 2 to power 9. The answer would be, this is the answer only. You can solve this by yourself. All right. These these category comes under not specified, not specified question. Next, we will discuss some questions on, let's say, unordered distribution. Unordered distribution is what? Uh, Distinct objects to identical boxes or bins, like that. This is the unordered distribution. Now, what is a question? These also have some type. Uh, Fully specified, specified first, second, uh, fully specified, partially specified, and third is not specified altogether. So now what we will do, we will take some questions to understand the question. Distribute 10 boys into three groups, into three groups, right, such as 2 comma 3 comma 5, right, boys groups. So groups are identical and boys are distinct. This is unordered distribution here and fully specified also. Fully specified, right? How can we do this? It will be like we have 10 boys, distribute 2, 3, and 5 in groups, right? So this is as simple as 10C2 we select 2, 10C3 we have select 3, and 10C5 we have to select 5, right? So not like that exactly. Uh, we will have to 8 and 5C5. This is the way, right? It will use 10 factorial above 2 factorial, 3 factorial, and 5 factorial. Same as limited permutation with limited repetition. Same as. Next question would be like divide 3 boys into 3 groups. Each group having exactly one toes. Each group having exactly one toy. Like one toy or boy. This is not the case. 3, 1, 2, 1, 1, 1. How many? Only one way. One way is there. Right? And it would be like direct formula would be 3 factorial upon 1 factorial, 1 factorial, 1 factorial. And it will be like 3 factorial, 1 only. Neutralizing the distribution. Here 3 factorial is neutralizing the distribution because groups are identical. Right. Now, next question is here like divide 4 toys in 2 groups, each having exactly 2 toys. Only one way is there? No. Divide 4 toys into 2 groups, each having exactly 2 toys. So we have 4, 2 and 2 here, alright. So this is, I think, simple. 4C2 into 2C2. Just like that only. So it is like 4 factorial upon 2 factorial into 2 factorial into 2 factorial upon 2 factorial. Like 4 factorial upon 2 factorial, 2 factorial. And like this. 4 into 3. These are repeating, so we have to put 2 factorial. Next question is also very important here. Next question is divide 10 toys among 4 groups where 3 groups having exactly two toy and one having 4 toys and one having 4 toys. Like 10, we have to select 2, 2, 2 and 4. What we can do is 10 factorial upon 2 factorial, 2 factorial, 2 factorial, 4 factorial, and neutralizing this 3 factorial also. Alright. One question is here like one note here is very important. But an permutation with limited addition, we don't do this. This is when I repeats itself with k times, we don't multiply by k factorial. Wait a second. What is her answer in English? What is that? Hmm? Her answer. No, Uh-huh. Numerator slash denominator. All right. So denominator meter we will neutralize distribution in the meter. So the note here is very important note that what the case here, like we are when it uh, when a number repeats itself n times, so k times, so we have to here multiply denominator with k factorial, but in permutation with limited repetition, we don't neutralize distribution. So is that when ni factorial repeats itself k times in denominator, then we don't multiply by k factorial in denominator like that. All right. This is very important. What we say development here we have done. All right. Next question we will discuss is, let's say, change the pen to change the field. Next question here is, divide two t objects into divide two t objects into, first question is here, two groups, each having t objects. Second is t groups, each having two objects. So how can we do this? We have two t objects. Right? For first case, you have two groups. Group 1 each having t objects. T. So t here, t here. So what is like 2t c 2t factorial upon t factorial into 2 factorial. This is the answer. Second case is, we have two t objects and 2 like t times, it is 2t factorial upon 2 factorial 2 factorial t is times into t factorial. This is how we do it. And for more simple generalization, 2t factorial upon 2 factorial to power t into t factorial. This is the answer. Right. If nothing repeats itself in denominator, then it works as fully specified distribution is ordered uh, in ordered distribution. Right. Yeah. Permutation. We don't utilize distribution and we specify distribution in ordered distribution distinct to also in ordered distribution distinct to be specified. Right. Second here is distribution is not specified. Question is divide 4 toys into 3 groups. Divide 4 toys into 3 groups is like. What is it is like? 4 toys we have to put 4 0 0 and 3 1 0 like that, and 2 1 1 1 2 1 1 1 2 is like this, like that doesn't show because 1 1 2 2 1 1 these three all are identical. So this is like that. So how can we do this is 4 factorial upon 4 factorial, right, plus 4 factorial upon 3 factorial into 1 factorial plus upon 2 factorial upon 2 factorial plus 4 factorial 2 factorial 1 factorial. Alright, now बता देते फोन मार रहा हूँ. Let's see some score. 149 for 215. Some Dubai is fired up. I'll put that one also. Right. Today both are on fire. Right. So let's start our discussion. Minute. we are doing is here is not specified groups. It's like 4 factorial upon 3 times selection 4 0 0. It is like 4C4 into 4C0 into 4C0 is like that. How it is 4 factorial upon 4 factorial into 4 factorial upon 4 factorial right, into 4 factorial upon 4 factorial is like this. This is all one case plus second case is 310. Alright, this is 4C3 into 4C1. 4C3 and 3C1 is like this, I think. Yeah. 3C1 and yeah, like that, and 2C0. 4C3, 1C1 is like 4C4 factorial upon 3 factorial into 1 factorial into 4C1 is like upon 2. Right. So what we are doing here is it's a very tricky question, I think. Yeah, very tricky. Hmm. So we will discuss them. If next question is like, let's say next type of questions is like here. Distribution is partially specified like that. Right? These are not important topic for GATE. Let me clear to you this. Right? So we have 30 players. How many ways to make two teams each of 11 players? So 30, we would select 11, 11, 22. So how can we select it? We have to select 22 from them, and we have to select from 11 to 11. 22 is 30 C22, and it is 22 C11. 22 factorial upon 2 factorial, 11 factorial, 11 factorial to 2 factorial. It's like that, right? Partially specified, and it will go for like 32C, 30C22 into 22 factorial upon 11 factorial, 11 factorial into 2 factorial, like that. Right. Next question here is identical to identical, like that. Identical to identical. In this, distribute 6 identical balls in 4 identical boxes. Question is distribute 6 identical balls in 4 identical boxes. How can we do this? We have 6 balls. We have to distribute them in 4 boxes. It would be like 6, all of them in this, then 0. Where is the net? Internet is here only. Alright. So 6, we can give 6 to one group, 0 0 for other, and we can give 5100, and next is 411 3111 2211, right? This is like that. And or what else we can do is 12 12 12 3 zeros like that, and so on and so forth. And 0330 like that. We can do 211 is 222 222 and 0 like that. Number of 9 ways. This we have to do it manually, so this is not important for gate, but important if it comes, then we can do manually. There is no formula for these type of questions here. So one thing was there is uh, next question here is let me see what is the answer here. All right. Ask me. Distribution is not specified. Question is divide 4 toys into 3 groups. So each step of question and explain it in details. Right? Let's explore how to divide 4 into 4 toys into 3 groups step by step. We will consider that each group can have any number of toys. So start with initial distribution. We have 4 toys. We want to divide them into 3 groups. Let's represent groups by A, B, C. To distribute the toys, we can distribute the toys in various. So, group A 2 toys 1 1, 301, 1 to 1 like that. Explain the concept. In some cases, we may have a remainder which has leftover toys. For example, if we distribute 4 toys into 3 groups, we can't always divide them evenly. If there is a remainder, we can create a separate group for it. Total number of toys. 21 virtual representation. Uh, solve it by combination formula. Right? So here what we are doing here like this. Number of ways is 400 is like same 431 350 250 258. 4 factorial 4 into 3 factorial dot factorial equally factorial 4 factorial 3 factorial. Alright guys, we did note that easy and not that simple also. 4 factorial 4 factorial plus 4 factorial 3 factorial 1 factorial 4 factorial. Thank you so much guys for watching the video. We'll meet you in the next